Today for our factoring review, we're going to work on the difference of perfect squares. But before we start these notes, we're going to go over yesterday's homework. Check your answers. You can always FOIL this back together. 2x and x make 2x squared. 4x and 1x makes 5x. And 1 and 2 make 2. Some of these you might be able to do by guess and check. And other ones you might need to do by making your table, using the box method perhaps. That's a type that we talked about in class. This one, when I multiplied my 6 and 12, I got 72 that add to be negative 17. I did not come up with a pair of numbers that also added to be 17. So I saw this one to be prime. Upon further review, I see what I did wrong. Maybe it's not so much prime. Let's do this one together. What multiplies to be 72 and adds to be negative 17, both numbers need to be negative. That's how you get a positive 72. That's how you add to be a negative. So just to start from scratch, we'd say negative 1 and negative 72, negative 2 and negative 36, negative 3 and negative 24, negative 4 and negative 18, 5 doesn't go into that, negative 6, and 6 is going to go into there 12 times, 7 doesn't go into there, negative 8, 8's going to go into there 9 times, and there's what adds up to be 17. Make your box. Bring in your 6m squared and your 12, your negative 8m and your negative 9m. Factor out what you can, a negative 4m. And we factor out the 3m, 2m, and the negative 3. So our answer, again, this would be a negative 4, not a negative 4m. So your final answer is 3m minus 4, 2m minus 3. And to test that, we get 6m squared, negative 9 and negative 8 make negative 17 and positive 12. That one tricked me for a second. So check your answers.
Must be your lunch. Allergy season will really get to you.
So check your answers. Okay, here these are a little trickier. You got to watch your exponents when you're multiplying them together. Add your exponents if your variables are the same. Now we'll go into today's lesson. So this is a little bit different. This is the difference of perfect squares. There's really a rule that we can use for this. Kind of makes a shortcut. It's relatively easy. So we're going to put in our parentheses. What we're looking for is two binomials that multiply to make this. Notice that there's no middle term. So when we do our FOIL, the middle terms have to cross out. So the trick here is to say, what's the square root of x squared? We put those here. What's the square root of your last term? 1 and 1, plus and minus. So when you FOIL this back out, notice what happens. These two terms will cross out, and you're only left with an x squared and a minus 1. So it worked. What we typically say for a rule is that if a squared minus b squared, if you have the difference, which is minus, of two perfect squares, then you're going to have a plus b and you're going to have a minus b. That's going to be the rule that you'll be able to follow. So here, perhaps, if you write the 16 as 4 squared, this is the difference of two squares. Then you can write x plus 4 and x minus 4. And if you were to FOIL that, you would get no middle term. Negative 4 and positive 4 would cross out, and you'd be left with a negative 16 at the end. Here, you can write this one as 2x, because that's the square root of 4x squared. So that's 2x squared minus 3 squared. This is the difference of two perfect squares. If you can recognize what the two squares are, then it's real easy to drop it into the parentheses. It doesn't matter which one's negative. One of them will be negative, one of them will be positive. The square root of x squared is x, so it's going to be x plus 12, because the square root of 144 is also 12, so x minus 12. Now pause the video and you try the next four. Here you would have gotten x and x plus 3 minus 3. X and x plus 5 and minus 5. Two x and x, 6 and 6. They have to be exactly the same. So we're going to have a plus and a minus. Now notice how we could have factored something else out of here. We could have factored a 4 originally. So if you can factor something else out, we now have to pull the 2 out and pull the 2 out. So that's actually pulling a 4 out. Maybe it would have been easier if I did that in the beginning, but you go with it for when you see what steps to do. This would have been 7x minus 9 and 7x plus 9, because 7 and 7 make 49, 9 and 9 make 81, and when you work through the rest of the problem, you get a positive 72 and a negative 72. So we'll practice the same procedure down here. So you take the square root. The square root of 9 is 3. They have to be exactly the same. The square root of 1 is 1, plus and minus. Square root of 4 is 2. Square root of 16 is 4. This is one of those, again, that I could have factored out the 4 ahead of time. Maybe it would have been a little bit easier to work with. So here I need to factor out the 2. Here I need to factor out the 2. And that would give me 4x plus 2, x minus 2. You want to be sure to factor it completely. Square root of 25 is 5. Square root of 16 is 4. And the square root of y squared is y. So it's okay to have two variables there. And what's inside the parentheses is going to be exactly the same, except the signs will be opposites. So when you get the O and the I in FOIL, you get a 20 and a negative 20. Two x and 2x, negative 7z squared, and positive 7z squared. Now pause the video and work on the next 4. Okay, for the ones you just practiced, number 5, take the square root of x squared and the square root of 4. Now this one I'll do with you. It's a little tricky looking. This is still your term that's being squared, so it's going to be written as your first term. This is the term that you need to take the square root of. So you have 5 and 5, a plus and a minus. So your final answer could be x plus 8, because 5 and 3 make 8. And x minus 2. The other questions were more similar to what we've been working on. If you ever have a question, you can FOIL this back together to see if it makes your original question. Negative 20 xy, positive 20 xy would cross out to make nothing in the middle. Okay, then we'll do our last 4 questions where we multiply these together. This says to use the box method. So when we use the box method to multiply, we put our terms on the outside. Multiply the 2. Do your row and your column. Your row and your column. So you have a 9x squared. Your 2 terms make nothing, make 0, negative 1. Probably wouldn't use parentheses around your final answer. Okay, using the box method. $2x and 7z squared, 2x and a negative 7z squared. Do your row and your column. Negative 14xz z squared, positive 14xz squared. So when you add those, they'll cross out. So your final answer are your two boxes. And then these last two we will multiply by foiling. Notice how the two middle terms are exactly the same, but their signs are different, so they cross out. Two middle terms are exactly the same, but the signs are different, so they cross out.